Hello. So I'm going to carry on doing some PCB work today. Some work on the WS2812, or well, it's actually SK6812 because they're RGBW LEDs rather than just standard RGB. But yeah, doing transmitting RGB LED data over RS485 for outdoor use. Switch to the correct. Where are we? There it is. So yeah, hopefully the audio is a little better today. I listened back to some of the recording from yesterday and my mic was clipping really hard, so let me know if that's still happening, but I think it should be okay. And also let me know if the music's too loud. I had a bit of a play around with it. I realised the levels were wrong last week as well. So, but as you can see, I have a PCB here now. So I did a bit more work on the schematic since yesterday. Tidied up a lot. The major differences are I fixed an error. Well, the first thing I'll say is I renamed a bunch of these nets. So these are now actually named after the positive and negative signal instead of being named just A and B. I want it to be more clear to me whether it is the positive side of the RS485 or the negative side of the RS485 signal, the differential signal. And they've also been marked as differential pairs in Altium. This probably won't make any difference. In the PCB design tooling, there's a lot of stuff for like length matching for differential pairs. But it's not really necessary for this. That's only really a concern if you're getting into, you know, like the hundreds of megahertz signals, where you really want to get the rising and falling edges to sort of land at the same time, particularly the rising edges at the right time, so that you know, you get the if you were looking at it on an eye diagram, you get a lot of space in that eye diagram, whereas in this kind of, you know, 800 kilobaud RS485, like that doesn't matter all so much. It's just if I wanted to do length matching and impedance matching and things like that, then I can do that with those flags. But yeah, you might notice obviously it's also a lot neater, a lot tidier. So one thing that is obviously quite important here is all of these termination resistors are actually for the output side, all do not populate, because that includes the capacitors as well, because on the transmission side, so on the driver side of it, there's actually no signals coming back, because obviously RS485 is bidirectional. It's half duplex, so it's the same signal pairs being used for transmit and receive. The idea is that you transmit, and then you stop transmitting, and then you receive. In this particular case, there's no receiving happening back into here. All of the signals are coming out of the control box and then flowing through these nodes and then going to just the nodes, and there's nothing else. That's it. So there's no signals coming back, so you don't need to terminate on this side. So obviously the termination resistors on the receive side are all populated, along with the TVS diodes for clamping everything down to plus minus 15 volts in case there's any sort of real, like the signals are really far out. I added a fuse on the input because, you know, a little bit of input protection didn't hurt. And also one thing that wasn't there before, although I think this has got the same problem that I found the other day. I need to fix this. Yeah, I added a TVS diode array to the data out because there's nothing protecting that. So on any kind of like hot plug event, there's a chance of like ESD, so like me touching it and zapping the whole board. So I just stuck a TVS diode in there. You'll notice these little dots on the end of here. I had a really weird issue earlier today where some of my components were getting 4 of each pin put on top of each other. So it would be like there's 4 of pin 1, 4 of pin 2, 4 of pin 3. It was very, very weird. I'm gonna have to go and look and see if this is also affected, and then also fix it. Decoupling caps are now in as well. There's now footprints for all of these devices. I've done a bunch more tidying up of, obviously it looks a bit nicer than it did before. I also remembered to change this. And one other thing that I noticed that I'd done, I actually had the on the outputs, I actually had the polarity of the outputs the wrong way around in terms of connecting to this sort of termination network. It was actually the negatives were on the top and the positives were on the bottom, which is fine for just this passive termination, but with the active termination that brings that has these resistors going to VCC and ground, that's actually really problematic. So it's a good job I caught that one. I mean, I know they do not populate anyway. They're all marked DNP, so it wouldn't particularly matter, but it means that if I did actually put those resistors back in, it would actually break. So the first thing I'm going to do, because I only just noticed, is fix this SRV05. There we go. Fix this SRV05 symbol, because clearly there's something weird going on here. In fact, I bet if I click on here and then click on pins, there's like, yeah, it's got 2 pin 1s, 2 pin 2s. Yeah, it's got 2 of every pin. It's very, very weird, and I can't work out why it was doing it. I just need to go into here and fix that. Where are we? Yeah, schematic library. So let's find where that is. It is here. Yeah, you see, I just deleted that pin and there's another pin underneath it. It's really weird. And one of my other parts was doing this, and yeah, it had 4 of every pin stacked on top of each other. Very, very irritating. So that's fixed that. So then I'll update this from the schematic. There we go, and the weird dots go away. Cool. So if I then validate the project, I see no errors, good, and I can then update the PCB document from that if there are actually any changes, which there aren't because it's just on the symbol that was changed. So the PCB. So obviously I've got all these footprints in here now, which is nice. And I've gone through and just sort of in preparation for the stream, organized all the parts quite nicely into just to sort of make it easier just to find things, so I'm not spending half the stream going, where's R4? Which is about normal for my PCB layout sessions, spending half of my time just looking for where the damn components are. So I've set up the board stack up already. I'm using, let me see if I can find it. I think I've got it here. Here it is. So I'm using JLC's 7628 stack up. So this is a 4-layer board. I know originally I was going to go for a 2-layer, but I decided I just want the 4-layer. So the inner 2 layers are planes, and there's a copper core through the center. So this is an impedance controlled stack up. So we've got 1 layer on top, 1 layer on the bottom, and then these 2 middle layers. I don't actually know whether these are electrically all sort of connected as one giant central layer. It doesn't matter in this case because my 2 inner layers are all just going to be all ground planes anyway. So it'll just be signal power, ground, and signal and power. Yeah, and I could have gone for the 2313 stack up, which brings the layers a little closer together. So this is 0.1 millimeters. I don't know if you can see that very well, but yeah, this is 0.1 millimeter prepreg, and this is 0.2. But the 2313, the weave in the it doesn't really matter, but the weave in the fiberglass is a little looser on that one. I prefer just to go for the 7628, and the 0.1 of a millimeter versus 0.2 of a millimeter doesn't make a whole lot of difference. at least not for what I'm doing. I'd have to think about this a lot more if I was doing something with, you know, in the 400 megahertz, 500 megahertz sort of plus range, going up into the gigahertz. You know, if I was laying out FPGAs and DDR and all of that, then I would start caring. Currently, I don't really care. The other thing I did was sort of pick an initial board size. So what I've gone for is 4 inches by 3 inches. That's kind of the maximum of what I want. So I already have some enclosures that I'm using. Was at least using to prototype with. I don't really want to go much bigger than the ones that I have. I can if I want to, if I have to, but I prefer not to. So 4 inches by 3 inches is quite a nice place to be for that. Yeah, the 4-inch length is basically enough that it's pretty tight in those enclosures. It's 4 inches is effectively 10 centimeters, and if I remember correctly, they're around about 14 centimeter by 14 centimeter internal dimensions. So if I can make these a little smaller, that'd be great. But then of course, well, this footprint looks like it's only 1 inch by 1 inch, so this is it's about 900 mils, I think, actually. Yeah, so these are actually about 900 mils long, so they're nearly 1 inch long. So you're using up nearly 2 inches of horizontal space just for the connectors. It's not so bad if you want to then, you know, route things sort of vertically and have things wrap around, but I'd rather it be a bit neater. Anyway, let's pop this over here. So this is actually backwards. It needs to be like this, and then I need to change my grid size because we need 25 mils this way. Yeah. So this footprint I actually got from somewhere else rather than making it myself, but somebody I did validate that it looks pretty correct. Like the hole sizes match up and everything. I don't have a 3D model for this yet, but I put in a request to make one because apparently it's like 99 cents to get one of these made. I don't know how they're going to make a, you know, Ethernet connector model for 99 cents worth of work. That seems like a lot of work for 99 cents. It's a little weird. I don't know whether they just have one in a library and you just pay for it and they reckon that they, you know, they say that they don't have it, but they actually really do have it, and just a trick to get you to pay for it because you think you're getting a good deal, but I don't know. So let's start off with this connector on this side. So I haven't really, I'm just sort of very roughly placing these things for now. Like it's not like I'm, you know, making everything really nice and well, any of this is like final at all. It's very much just rough placement for the moment. Sorry, couldn't think what I was trying to say there. So the first thing I want to do is try and get the ICs positioned. So we got 1 through 4 on this side and 1 through 4 on this side. And if you look, you'll see that the ground pins are actually in the opposite corners. These have been rotated by 180 degrees. So I'm going to do that now. So these have got the ground pins in the top left, I believe. Oops, that's not what I wanted. Where's that one? Yeah, so pin 1 is in the bottom right for these left ones. So these need to be 180 degrees rotated. So if I then bring these down here. Nice. The other thing is that with this, one of the benefits of using this in the high precision controlled stack up, this is actually free. If you're getting a 4-layer board, you can just upgrade to this for free, and it gives you 3.5 mil tracers, whereas I think the default is 5 mil for the other services, and that comes in really handy because so this is what a that's not a 3.5 mil trace. What on earth is going on there? So that's a 3.5 mil trace. That's tiny, and that's very useful for when you're routing through these gaps here, because I'm gonna have to get 2 signals through some of these gaps. In fact, if I just show you very quickly, so one of the issues was which thanks to Ati yesterday pointing out that these signals here have to cross over. Now, I don't want to do that by swapping layers if I can avoid it at all. So what I figured out that I can do, if I can find, here it is. So I just drew this in whiteboard. Oh wow, there we go. Sorry, I'm not used to doing this with just a mouse in whiteboard, but if we've got these signals, 1A, 1B, these should actually be positive and negative, but you get the idea. 1A, 1B, 2A, 2B, blah, 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 blah. They need to actually be in a different order, because you can see here that the 1A and 1B and 4A and 4B are in the right order, but then it goes 2A, 3A, 3B, 2B, because this 2A and 2B get sort of, they get sort of split out. Because of the way that the wiring works in Ethernet cables. So the way I figure is I can route these round the back, which means I need to squash in two lines between, and these look like they're really far apart, but in the real footprint they're oops, no. Yeah, in the real footprint they're this far apart, which is not very far. It's not very far at all. So, yeah. Weirdly, these look swapped as well. And I'm not sure why. PN, PN. Did I do this wrong? PN, PN. Oh, no, I'm correct. It's supposed to go up and round. It's just the rat's nest looks crossed over because of the angle between the part and the one. So, weirdly, it's setting my trace width to 15 mil, which, no. And why is that not letting me set it to 3.5 mil? Have I got, like, weird net rules or something? Let's check the design rules. Oh. No, wait, that's not it. Width. So the preferred width is 5, and the minimum width is 3.5. What? Have I got a net? I forget where the net list is. I got a. Is it in the PCB list? No. Can't remember where the net list is in this. Is it under PCB? It is under PCB. It's under nets. Although, I can't see why I have no nets. That seems wrong. What's going on here? Where's my thing? Oh, that's why I can't select that. There we go. So, selecting this, and then jump to the net. Nothing in there about... It's very weird that it's not letting me change this to 5 mil. It's setting to 15 continuously, and I don't know why. Yeah. It's also weird that this says like bottom layer is layer 2. So I wonder whether that's it. Like if I had a new rule now, does that fix it? No, it doesn't. It's really odd. Yeah, I've got differential pair rules in there, but that's normal. Yep, top and bottom layers are also marked as routable. This is very strange. So it shouldn't be under clearance, it should just be the standard width rule, which I really don't understand because the preferred is 5, the minimum is 3.5, and the max is 30. So why? Okay, and now suddenly, why is it that these specifically? Oh, is it because differential pairs are being treated separately? I bet they are. Because that's the only thing that I've changed is I mark them as differential pairs. So I bet it's somewhere in here. See, I haven't used the differential pair feature before. And of course, just me deciding to use it has suddenly decided that it's going to... Here we go, yeah, minimum width 15 mil. So yeah, I'm going to go with 3.5. It may also screw me on this 10 mil gap. But let's find out. So this should come again. It's doing weird things, but let's go to 3.5. Ah, see, now it works. Yeah, so it was that. And I'm also just going to change the rules there slightly because the preferred width is still 15, which I don't like. I think I want the preferred to be 5, like everything else. There we go. So, what's going on here? Let's, let's route this up. And you see, because I've got this on a grid here, it's trying to snap it into this center point. So I'm going to change the grid to 10 mil because now I can get this nice and... Oh, actually, that doesn't matter in this case, I don't think. What was the, what did I do here? Yeah, okay, so for these two, actually, I do want it to, yeah, I do want to have it just go straight into 25 mil. There we go, straight into the center here. And then I'm going to bring these nice and close together. Should be fine. And then let's do this. This is where you can see that the this in 3 here goes round the other way. Well, that's odd now I think about it. What have I what did I do with the oh yeah, I was right. There are 2 signals routed through this. So if I change the grid back again, wasn't thinking, oops, don't want to move that. There we go. Actually this that I want to move down. And that means I can then route, yeah, let's go up like that and then across. And then this can come nicely up here. There we go. I think it's gonna, yeah, it's throwing a DRC for some reason here. I don't understand why. Not quite sure why that's complaining about something being under 10 mil, but whatever. That might be the annular on the pads on this part. I might need to go back and fix that, but that's fine. And then again, we can get these nice and close together. It's interesting actually now that I'm looking at this, that how did I intend to route this? So 3B was supposed to just come around the back and 3A goes that way. Oh, okay. So this next one's going to come round through here and into here. I guess that is the only way of doing it. Yeah. And then this one comes along and goes straight in here. I suspect it won't like this, because what I really should have done here is, let's get rid of that. What I really should have done here is, yeah, move this over. So this follows along as closely as possible. Right until the last minute, and then it just decides to go up and this way. So that way they sort of sit next to each other nicely. I'm not sure why like some of these are cross-hatched and some of them aren't. And also, why does that look like a weird size? Yeah, why is that 5 mil? No, I don't want that. I want the... There we go. Yeah. Wait, what? Why did it do that? That's weird. Yeah, that should be 3.5 mil, not 5 mil. So, interesting. So if I validate, yeah, it's all valid. So, and then finally, this should be trivial. And again, it is 3.5 mil. And I think for this, I'm just gonna sort of, yeah, go straight down. Largely because then I can have this one come across. Go like that. Seems fine. It also seems like I could move those closer. I think I could probably move those closer. Unless there's anything on this side that actually needs to be... the VCC might be a little tricky. Because I need decoupling in here as well, but then I think I can still get the, haha, yes, they are some thin traces. Yeah, 3.5 mil. But they're, the minimum that, JLC can do, but, you get automatic, they do full testing, for free by default, so it doesn't make a difference. Like, if it doesn't work, then, you know, like if there's any shorts or anything like that, they just make more boards until it works for free, so I'm happy with that. And I don't think I can get the 5 mil traces through these gaps. Really get the coupling, not that it really matters, I just like it looks neater. But I might redo this, I don't know, because I don't want them so close that they like, yeah, I don't want them so close that it messes things up, but I don't want it, I want to not have, I want to basically try and cram this in as little horizontal distance as possible. What I really should have done is put all of these in the right places first. Let's change my grid over. Oh, fun. I didn't put those on a 50 mil grid. Damn it. I think I put them on a 25 mil grid, which is also fine, I guess. Yeah, there we go. So, this bit in the middle can potentially be a little on the... I want to turn that off. There we go. Yeah, this bit in the middle might potentially require a little bit of routing space because the I've got to get this 8-pin connector in for a start. So this has to get in there. I also need to get the, there's a TVS diode that's going to go in there. So that's new. So that's got to go in. I really like this part. It's a SRV05, I believe. Yeah. This SRV05-4. It's a SOT23 6-pin part, and it's got 4 TVS diodes. It's actually got. I'll show you the footprint here, so it shows you quite nicely. There it is. So you get these clamping. TVS clamping diodes, where you basically got 4 signals that you can clamp. It's 5 volts. So this will clamp the signal quite nicely to 5 volts. And also, it comes with a Zener built in across the supply. So if you've got anything with USB, this thing is great. Like, you just drop this on a USB input and job done. That's, you know, you got your voltage clamping to 5 volts, and you've got all your ESD protection and everything all built into one package. And the other reason I like it is because let me see which way around I've done this. So pin 1 is to IO1. Oh, pin 1 is IO1. Oh, that didn't help. Anyway. Yeah. Yes, so if you see here, I've got it channel 1, channel 2, channel 3, channel 4 in this like sort of anti-clockwise direction. One of the cool things about this is that you can route it really nicely, because you can do... I've got this backwards in relation to this because this is upside down. P2 is backwards because you've got channel 1 on the bottom, so it should be the other way around. But yeah, so as you can see, it's dead easy to route, because you can just go channel 3, channel 4, channel 2, channel 1, yeah, and then you can just put a wire to ground and VCC, which is lovely. So I'm going to move this quite far over, because yeah, I really want this to I need to get enough space here to be able to do the pair switching with all the wires and everything. I did draw something for that, actually. Just one moment. Yeah, this thing, which, you know, my very crudely drawn schematic of how I'm going to do this, which is basically you use a wire to switch layers, and then signal comes down, signal comes down, signal goes up, and then there'll be ground wires next to each of these for referencing. But on this side, it becomes very easy. Now, for these, I can actually switch back to 5mm, because I don't need to route in between all of those little holes. So yeah, we can go straight from there to there. That's there. Let's come up, over and across. Let's do the same here. Up, over and across. Yeah, whatever. So it's quite nice. I think I might redo this on the left anyway, because like that's a lot of dead space that's just not necessary. I do want a little bit of a gap, because if I want to be probing any of these pads, I don't want to be butted up right against the back of this Ethernet connector. That's just going to get really annoying. It's going to frustrate the hell out of me. I also think I can probably just squash these ICs closer together. I'll decide that later when I've moved things around. So yeah, these TVS diodes. Oh, actually no. Yeah, so I've missed something massive out already, which is I've got to squash all these TVS diodes in here, because if you take a look down here, yeah. So between each pair, I've got to get these TVS diodes. Now, it doesn't actually have to look like this, because I can do. Oh, that's a very good point as well. On here, because I've marked these as DNP, so if we look here, there's no path to ground here. So that wasn't very smart, was it? So in this particular case, these actually... Oh, I hate doing this, drawing these sideways. That's so ugly, but it needs doing. And I'm gonna update the PCB. Cool. And then on this side, I'm just going to quickly validate, and there we go. That's fine. Yeah. So if all of these parts were, populated, then we have this flow through this capacitor down to ground. Although I think this would still be wrong. Yeah, this would still be wrong actually. What I actually want is to get rid of those, and that ground should just be permanently there, because yeah, the terminating resistors should flow through the capacitor to ground in this center, because that forms an RC filter for high frequency common mode noise, whereas with these they do need to just go straight to ground, which means that this is also wrong on the top. It's a very weird piece of music. Incredibly strange. Right, so yes, which means that so TVS 1 and 2 I believe sit here. Yes, no, it's TVS 1 and 5. So 1 goes here, and then 5 goes underneath, and because of yeah, you see, I am going to need to move these over. But yeah, because of the way this is laid out, you can actually move you can have these on the outside. They don't need to go between the pairs, so that's quite useful. But yeah, I'm gonna have to where are we? Tracks. Just select all these tracks and delete all the tracks. There we go. Let's move these over. I think they can go closer together vertically, but we will find that out at a later point. That's also far too close. Like, the rooms for these are actually touching. So, and also while I'm at it, I'm just going to put everything on a 50mm grid. It's not necessary, but from that, which it has to sit on a 25mm grid. I just kind of like, when I'm laying things out, I like things to sort of sit on a fairly coarse grid, just because it gives me a bit of a sort of nice idea of where everything sits. So yeah, so this also needs flipping around. So you can see that this in1 negative and in1 positive are on the inside, and then these can go to ground via vias, or vias if you are American. Yeah, I kind of... Yeah. I'll move all the silkscreen stuff around later anyway. But then, yeah, you can see that these will not be able to go that close together, because you'll need the TVS diodes, and then their associated vias as well. So yeah, because I can't move these any closer. I could stagger them, but I'm actually more bothered about this horizontal width than I am the height, because this is 3 inches, and I can go up to about 3.5 on this, but I don't think I even need the 3. Like, vertically, I think it's not that tight. So I would rather not stagger these. I would rather just have this. Yeah. So I'm going to place a via just for the sake of it. I also think that's a massive via, if I remember correctly. Like, the default on this is something huge. Yeah, that's like a 28mm via, which no. Like, for comparison, it can go as low as 7mm, which I'm not gonna, because why would you? But I'm gonna go for like a, I don't know, maybe like a 15mm with a 30mm. Yeah, maybe. I don't know. Maybe 25. Like, that seems fairly reasonable. And then, of course, switch back to a 10mm grid for this. Well, that was on a 10mm grid. Interesting. Yeah. Wait, what's going on here? Odd. Oh, it's because it's a... Yeah, okay. It's because it's on a weird grid. So I think it's fine for the... Like, I think it's fine for these to just slightly overlap. I think. Might just move it out just for the sake of it. There we go, that's better. So yeah, so this is ground. Yeah. So then I can just sort of, oops, I forget that when you copy with this, it does odd things. So this would actually, it would go further down. So I believe it's then, yeah, 2 and 6. So, assuming that these are 3.5mm tracers, yeah, I don't think these actually, I think these can actually be very close together. Like, almost touching even. Like maybe that kind of size. Like, what is that? Why? So it's like 10mm gap, which would mean, yeah, I'm pretty sure you could then just effectively follow this. Yeah. Huh. That's weird. So, okay. So this needs to come up by what? Or is it the other way? It's the other way, isn't it? Yeah. Why is that like on a... What's going on with that? Yeah. Weird. Why is that not on a... Why did they not line up? Are they not? Ah, because that's not on a grid. Okay, that makes more sense. So I think that's equidistant. So when I come up this way, yeah, so that's nice and equidistant. And you can see that these are now like positive and negative. Lovely. So you can then quickly and easily tie those together. However, when I do connect those up, I'll probably end up using slightly wider tracers, or even a maybe even a yeah, maybe even a the word I'm looking for? A polygon to connect those, because you want a lot of current to be able to flow through the TVS diode. In fact, you want it to be the preferred flow, the preferred path if there's a high voltage transient, which means you want the lower resistance through that than down there. So might be worth putting a polygon there. So effectively just like a nice big polygon. But for now, this is just for sort of mapping out how that looks. So then what governs the position of this next chip is we can move that there, and then this here. So then we've got ground, and a wire there, which then means that the position of this next one, my bad, there we go, is such that these center two pins are also, like, effectively you're doing the same thing here, where you're keeping them sort of equally. Just make sure that that one's also on the grid. It is. So then 1 and 2, so that goes 10 mil either way. Yeah, so that's quite nice, because again you get this. I think you can actually, yeah, no, the 5 mil is too much, but the 3.5 mil is spot on. Although weirdly it set these to 5 mil first. And again, this comes up this way. It's weird that these, like, oh, I see why. Yeah, okay. So what I did here, oh, that is odd. That is very strange. Why is that like that and that like that? That is strange. Is that a different distance? No. Whatever. I don't care. It's weird though that these traces route differently. You see how these like sit across, even though that they cross this point here. And these are in exactly the same position. That is weird. Oh, I see why. The traces didn't join at the same height. See? It's pretty. Yeah, I actually prefer it the other way. And it doesn't matter. I get way too like bogged down in the aesthetics of it. I'm really bad at. I'm really bad for it. It's yeah, I really shouldn't. Yeah, that's correct. So then I need TVS 3 and TVS 7. Which get the ground on this side, and it's there, and then get the ground on the other side, and then we go. And obviously this text will get moved around. Yes, classic Altium behavior. It's actually better on this one because they start closer together, but I don't care enough to like get that minute with the details. He says, or I may well care that much later date. Oh, and I just realized something else. So the TVS diodes are in here, yeah? I also need to get all this crap in there, so I'm going to have to move all this across as well. That's why you don't start routing until you've laid everything out. So this needs to it's like there? No. Nowhere near. it's there. Yes. Yes. So then we'll move that one. Oops. And we'll get one more here, which I will tie to ground. That's correct. And then I think we have one more, don't we? Yeah. So all of this needs to move up for a start. So this would actually be further up. Like here? I think that's right. Yeah, I think that's correct. And then we need TVS 4 and 8. Oops. Oh, right, yeah. So leave, but that's correct. It is, yes. And then finally this comes in here. Oops. Wait. Ah. Oh yeah. So then this comes down here. Yeah, that's correct. So that's quite nice. We've got VCC here. I'm going to put the decoupling caps on the lower side, I think. So that's, I think it's C2 starts. Yeah, C2 is the first decoupling cap. And that's... It actually doesn't matter which ones I use for which here because they're not tied to a particular device. They're just... Yeah, there's nothing to make me put them. I could put them in any old order. So sort of there will do quite nicely. Yeah, the text. Let's move the text. So that's fine. It's the same with C3. It was like here. Seems about right. Yeah, that's looking quite nice. It's also quite nice when your parts sort of land in a particular way where it's really easy to do things like, oh, I need a ground for this VCC to decouple into. Oh, look, there's one right here. Like, that's really nice when that happens. I like it when that happens. It's and it certainly happens more than would by random chance, and it's largely because of just the fact that, you know, typically you're going to have these types of parts all sort of connect closely, like flowing together in your circuit diagram anyway. But still, I like to believe that it comes out of some sort of level of skill, even though it is almost certainly just complete chance that it works nicely. Now, for these end ones, I could put the wires like right on the end here, but I'm actually going to move them across because that way they're closer to both of these, rather than... and in fact, I may move all of these across and have them on this side, because then the decoupling caps get a closer link to ground, and it doesn't really matter for the ground pads of these. So for now, I'll put it in the same place as the rest of them, which I think is just like slightly to the left for some reason. That's also ground. So all of these have been marked as ground. Yep. And then I've got one last one which goes up here. And this becomes also ground. Yeah. So then I can move all of these across. I think like right there is quite nice, because okay, for this top one I don't really need to do that, although there might be another reason to do that. In fact, there is another good reason to do that, and in this particular case this can actually come over here, because there's going to need to be a yeah, there's going to need to be a ground wire for the for this particular pad anyway, so I think that's fine. In this particular case, this one makes sense to be here because you've got this sort of ground comes over this way, and arguably I could have like this moved further over here, but I think for this case I'm going to because this is the ground pad, this top right one here is the ground pad, the actual ground pad for the part. The rest of these are just signals. So what I will probably do is it doesn't really matter, but I'll probably just have another wire here and then have all of these connect over this way, rather than having this like weird like flowing thing over here, because the middle two are all ground planes anyway. And you can, I don't know, we almost certainly can't see, but the two inner layers are called int 1 and int 2, both marked as grounds. So that's looking quite nice already. Yeah. Excuse me. So the the funny thing about here is that this will get moved slightly. Like it'll probably sit more like, yeah, more like here or here. Yeah. But you don't need a ground wire on this side because that's a ground wire. Like it's a through hole pad, it's a wire. So these can go nicely up to here and just connect up. Although, no, they can't, because this channel 3 line also has to route up. And while what I could do is I could go ground to here, and then channel 3 comes up and then round. Like that's fine. I guess I could do that. Kind of like I don't like running things underneath if I don't have to. Hello, Pyro SP. Hello. I am trying to pay a little bit of attention to chat, but I might miss your messages for a little while if I'm sort of very much focused on what I'm doing. Excuse me. Right. So the next thing I want to look at here is probably all of the horrendous like input termination mess here. So we've got R5, 6, 13, and 14. Which means that all of this needs to move across, and I'm going to put this in like 100 mil grid mode because, of course, I am. I'm going to do that. Yeah, so we got, what is it? It was R5, 6, 13, and 14. R5 and 6. It does help if I'm looking at the right parts. And then 13 and 14. Oops, not 12. So in this particular case, we've got this sort of positive side. Oh, I've got 100 mil grid switched on. Duh. 10 mil. So these capacitors, so in the last stream I was talking about the termination resistance, and it turns out, yes, I had calculated it wrong. So what I had thought was that because the characteristic impedance of the Ethernet line is 100 ohms, you would only want, and you need a termination resistance of 120, it would effectively form 50, whatever you've got across the end, and then another 50, making 120 if you put 20 ohms here, but that's not true. The characteristic impedance of the line is if you have an infinitely long wire, which means that there's no actual resistance on the end, it's just an infinitely long piece of wire, such that only the impedance of the wire will exist because there's no return path effectively back through there. It's through a loop, really. But you would only ever see, it would be the resistance that you would effectively see at a frequency, which is the impedance. So the characteristic impedance is that, which has nothing to do with line termination. Line termination is just the actual like bulk resistance that you would see at the end, not bulk. That's not what I was trying. That was not the word I was looking for. Lumped. The lumped resistance that you would see at the end of the line. So this does need to be 120 ohms. The nearest I can get is, although now I think about it, 120. Oh. Well, I could have just put 120 ohms on here for some reason. I didn't. Why did I not? Yeah, these should have just been 120 ohms. I don't know why I picked 118. Oh well, there are 118 ohms, and I can't be bothered to fix that. It doesn't matter. It's so close anyway. And there is a little bit of resistance in the line anyway, which I calculated out here. So yeah, I wrote here. So basically the characteristic impedance doesn't matter. The first run is 4 meters long. So the total resistance is either 0.4 or 0.28 ohms in each direction. So either it gets to 118.56. 118.56 would be what we expect on a Cat6a. Or it'd be 118.8, which is so close to 120, it just doesn't matter. It doesn't matter. Like, who cares? Like, honestly, I could do this with 100 ohms and it wouldn't make a difference at this frequency. Well, at least it shouldn't. So yeah, and then the power is B squared over R. So if you've got 5 volts, that's 25. In fact, it may be more than that now I think about it, because I think it'd actually go about as far as 7. So what's 49 over 118.56? So that comes to 400 milliwatts if I did that. So yeah, I went with 2 quarter watt resistors, mostly only because I couldn't get half watt ones. So a pair of these in parallel, which gives you effectively 118 ohms across this whole element here, because these in parallel become half and these in parallel become half, which forms, it's the same deal. So yeah, this is fine. I don't know why I didn't pick 120 ohms. Maybe I just assumed that 120 ohms was not a standard value and just didn't check. I might fix that off stream before going to production, because all that really means I have to do is create another model, create another component, and then do a swap, and then just update the board. And since they're the same size, because this is there's another 1206 that's in the. Oh, wait, are these 1206? These aren't 1206, are they? Yeah, they are. They're 1206. So yeah, there's 1206 parts that I can just flip and replace. In fact, off stream, what I might end up doing is replacing them with these 120 ohm 1/3 watt. Although they're twice the price for a fraction of the wattage overhead. When I say twice the price, I mean they're a penny, not 45% of a penny. So, you know, big money. Like, I don't care. The reason for using 1206 is because they're quarter watt parts, and I couldn't get quarter watt parts in JLC PCB's basic stock range without going to 1206. For this board, I'm mostly sticking to like 0603s, 0805s. JLC can do 0402s, but you have to modify the IPC compliant footprint slightly, because the clearance between the pads in the center, you need to shorten the pads slightly on the underside and move them apart, because otherwise they'll end up too close on 0402s. So you can go as low as I think you can go as low as like 0201s on JLC. You just have to manually tweak the parts from the footprint guidelines. Yeah. I'm using their services. I actually have my first ever assembled set of boards from them coming on Tuesday. That's some SK6812 high precision I2C temperature and humidity sensors. There's some breakouts for those, so they're coming on Tuesday, which should be fun. So yeah, so for each of these, we've got these R5, R6, and then R13, R14. Let's move these over. And yeah. So actually, yeah, in practice, this is going to get tricky, because technically speaking, what should happen here is the I might need to route part of this on the underside of the board, because no, why does it keep asking me this on here? Every time I click on this, it's like, do you want to update your changes? But I haven't made any changes, and it's concerning me. Like, what have I done here? Why is my core set to 4 mil? No. And now it's going to save this change, isn't it? Now it is. Where is my stack up? There's Stack Manager. Here we go. Yeah, it's those ones that I was working on. Yeah, this is set the copper core to 4 mil. What is going on here? I can tell you it is definitely not 4 mil. It is about 10 times that. It's 40 mil. I think the rest is correct. So that should be 0.035 millimeters. That should be 0.2 millimeters. Yeah, so the rest of this is all correct. I must have just caught something and messed up this core. It's a good job I spotted that I'd done that. So yeah, this is going to get interesting, because technically speaking, these tracers should go up and around, and I kind of want to keep it together. Not that it really matters. It doesn't really matter. But I kind of don't want to... Like, if you... there's a talk by... What's his name? Rick Hartley, who is a genius. And it's called What Your Differential Pairs Wish You Knew. And he explains the whole thing about routing differential pairs next to each other. It doesn't make a damn bit of difference on a PCB. You can route them all the way around the outside of the opposite sides of the PCB, because these are two on a PCB when they're not twisted together. They're not. There's nothing magic about them being differential. They're both referencing. They're two single-ended signals referenced to the ground plane below. That's all they are. So it doesn't actually matter. I'm just being silly. In fact, yes, I am being silly, and I'm going to take Rick Hartley's advice because he's much smarter than me. And I am going to do this the right way. So I'm going to have it so that these go up and around and then go back together. So it's kind of like this. It's about right. Yes. Length does matter. Length matters, as long as they're roughly the same length. But that's another thing. People pay too much attention to that as well. You put a table in that talk, and it's the amount of on a 100 megahertz signal, you get like, it was something absolutely bizarre. Like it's like 5 centimeters of leeway or something, where you can land in the right spot and you will never get a problem. It's actually quite surprising how much leeway you get. It's like only when you get into the gigahertz range where it's like you really have to worry about millimeters, but like it's still, you've got a millimeter or more of length matching there, which is like, that's a lot for something like that. So yeah, one thing that's going to get kind of interesting here is that, oh no, that's fine. That's actually fine. Yeah, I should link his talk. What your differential wish you knew. Here it is. And also, like, where is it? There's a... Is it? This is it. So, I've been pushing this talk on Twitter a lot because it fundamentally changed my understanding of how electricity works, and even like how it completely changed how I design PCBs. And like that second link that they're talking there is, I think every person who does anything to do with electronics should watch that talk. And everybody that I know that has watched it has learned something from it, including my dad, who's like a 40+ year EE veteran. He's changed how he made his PCBs after he watched that. So I cannot recommend it highly enough. Like, I feel like there's no better advert than that. But yeah, I am quite a in this house we stan Rick Hartley. I have no choice but to stan. There we go, C10. So that's going to be the cap that goes on this side. Actually, it needs to go the other way. So there we go. Yeah, I really, really, really recommend watching those. They're really good. Like the PC board stack up one, particularly, is 100% worth watching. The second one, the first one I linked, is also very good, and very useful if you do anything with differential pairs. But that first one, I think, is just fundamentally critical. I can't think of any other piece of media about electronics that I've watched that's had such an impact on the practical on my practical understanding of electronics design and PCB design as well. It's quite something. Right, what am I doing here? Yeah. So what's going to happen here is I'm going to move that slightly further out. Yeah, and I think those can go up like that. It's quite nice. And then, yeah, and then we'll have another ground wire here. Yeah. So what's going to happen is these signals are going to go up around the outside of these, which is why I was like, oh, do I want to? But it doesn't matter how close you route them, as long as the lengths are roughly the same. And because I'm only running at 800 kilobaud, it doesn't matter. I could route them with probably 5 centimeters difference in length, and it wouldn't make a damn bit of difference. So yeah, I like that as a layout. I can't remember how to. There we go. Doesn't that look pretty? There we go. Oh yeah, sure. So yeah, I probably should have done a bit of a longer intro and sort of explained how it all works. So this board is so I've got a large metal permanent gazebo outside. It's 3 by 3 meters. It's got a polycarbonate roof, and the roof, the way it's constructed, is effectively a series of 2020 aluminium. I don't know if it's aluminium or steel, but extrusion. So it's got the T-slots in the bottom, and then the panels sit on top with sort of covers to join it all together. And what I'm doing is I'm putting lighting channels. I'm basically connecting those with T-nuts to the underside into those slots in the extrusion, so that effectively I've got lighting under the gazebo, RGB lighting. In fact, it's RGBW because I'm using SK6812 LED strips. So the plan is that there'll be a control box in a cabinet on attached to one of the legs of the gazebo. That will have a power supply and a control board in. The control board will have an ESP32 in there, and the power supply is 24 volts. The control board has a low power step down to 5 volts just to drive all the logic on there. That's fine. Then effectively what's happening is the ESP32 outputs standard. Yeah, exactly. It's like 9 centimeters. It's not quite so much to do with the quarter wave because of the. It's actually to do with how much timing jitter you can accept. But yeah, the timing jitter is still quite a lot for something like this. Anyway, yes. Sorry. Yeah, the control box will have an ESP32 which outputs standard like fast LED or whatever signals from it. Those will then go into RS485 transceivers because the way that the fast LED stuff works is actually just it's a timing based like ones and zeros kind of. It's not like multiple voltage levels, so it's just a high voltage, low voltage, high voltage, low voltage, and it's just timing based. So when you push that through an RS485 transceiver, that actually works quite nicely. It's effectively just like a differential driver. Like you could just use LVDS or something like that, but just RS485 is quite convenient because it's outside. I want it to be differentially signaled. This board is going into one of the so there'll be 4 of these, and these go into junction boxes that sit on the roof of the gazebo, and basically what this does is it takes over so the 4 channels of LED data will come out of the controller, and they'll go over Ethernet cabling, so probably Cat6a shielded, and that will be plugged in through standard RJ45 connector. That will then run up to the first of these junction boxes. So then this connects into here, and this board, effectively, all it's doing is it's taking that signal data, turning it back into readable data, like LED data, and then converting it back into RS485 for the next channel. Now, I know I could just basically flow the RS485 data all the way through and only decode one on each side, or decode all four on each side, because I want it to be repeatable. However, just for reasons of because the total cost of all the parts is really low, I would much prefer to decode and re-encode the RS485 at every node, partly because that means that I can reuse this board in a different design where potentially I might have much longer distances between nodes, but also because once I've installed this, I don't want to be back up on a ladder, like faffing about trying to debug things, waiting for dry weather so I can take my laptop and a picoscope or something up there to probe around. Like, I just want it to work. So adding in additional like the RS485 transceivers, like adding 4 more chips in there, the cost is very, very small to me. And if I spend even an hour working on it for maintenance afterwards, it's cost me more than the cost of the additional parts 10 times over, so might as well. But yeah, that's effectively what this does. Yeah, the idea is that there'll be 4 LED strips, and then each of these will just one of these pairs of pins in the middle, so each of these is a channel, so it'll just take one channel off. That will go down to one of the LED strips, and then also in each of those junction boxes there is a 24 volt to 5 volt buck converter, so that'll take the 24 volt DC input and then drop that down into 5 volt DC high current, because I don't do anything that isn't massive overkill. The power budget for this is having every single element on full blast, like 255, 255, 255, 255, every single pixel. And I don't remember the exact pitch that I picked. I believe it's 60 per meter, and that's 3 meters per run. So it's going to be very bright. So yeah, overkill. Which means that that's one of the reasons that I'm running 24 volts and then dropping that down to 5, because the current requirements were just going to be absurd, and for one, low voltage high current supplies are really expensive, and when I started this project, which was actually several years ago and then just didn't get around to finishing it, I didn't have a very high current 5 volt supply. Now I have a 400 amp 5 volt supply sat around here somewhere, which is a beast. In fact, it's so powerful I can't get my I don't actually have an electronic load that can test it. They're supposed to be several £100 a piece. I found somebody selling one on eBay, not knowing what they had, and I got the pair for, I think it was like £75 or something. It's ridiculous. So I got 2 of them. It's a lot of current. So that's going to be for another project. But for this one, it's 24 volts and then dropping down to 5 volts. The incredibly high current ones are going in a project that involves lots of LEDs and bus bars. So that's going to be fun. Yeah, the problem for this one was that if I wanted to do it all in 5 volts, the current was going to be so high that the cables would just have to be like this. Otherwise, you just get loads of voltage drop. And also, I need to power both ends of the LED strips anyway. And I really didn't want to have like big, heavy cables snaking across the whole top of the gazebo. It was going to look ugly. One of the things is that you would think that it wouldn't matter what goes on the roof, but part of it is that you can see through the polycarbonate panels anyway, and the other part of it is that if you look out one of the upstairs windows, you can see down onto the gazebo, and I don't want a big mess of crap on top of there. I want to reasonably neat by my standards, which is not that neat. But yeah, the bus bars project is that's going to be a fun one. That's going to be a fun one. That involves. I have a lot of LEDs in my house, and that involves more than I have in the house at the moment by a wide margin. But that's one for a little bit of a later time. That's something I've been working on for a little while, and yeah, I'm hoping that it will be ready in 2 years' time, like a year and a half's time. Because that would mean I can take it to a certain hacker camp, and it'll certainly be a landmark. Yeah. Part of the reason for that being a big project is cost. That's a lot of LEDs. But yeah. So let's see what this next set of... So 7, 8, 15, 16. Well, I think I like this as a layout because you basically get the signals going around the outside, and then you get this center thing sort of all going together, and then this goes into ground, and it's nice and compact and flat. Like, I could move these closer together. I think I might. Like, how much does that... How close does that look? Well, that's not bad. That seems alright. Like, that doesn't seem too close together, right? And particularly because these pads are all connected anyway. Yeah, no, I think that's fine. In fact, I might even... No. Let's be sensible. But, yeah, I think squashing those together is not a problem. And I think I can even... Yeah, I think I can get away with that as well. Yeah, I think I like that. I think I might move the ground over just like by that much. Yeah, I think that's okay because these signals are going to go around here anyway, and then these are all connected together, so that doesn't really matter. These pads are connected, so they're close enough. It's just I don't want this... Yeah. No, I think that's actually okay. Yeah, I think that's fine. So this would go... Like, this would look like... this, I guess? I just obsess about not having these, like, really tiny corners. I don't like the little tiny corners. That's too big a corner, so what? There we go. You know what I really should have done? Route it from this side. And that looks much shinier. It's weird how this, like, doesn't... There we go. Yeah, like the 90-degree ones, it doesn't actually matter in most cases. Like, there's very few cases where you have to care about that. But I think it looks ugly to have like really, really, really small tight corners. Like, I think that looks quite nice. And then from here to here, I'm just gonna go like absolutely silly with this, like 30mm trace or something, because who cares? Like, that's fine. I don't know why this shows up as hatched. Is that violating the rules or something? Oh, I bet that's violating one of the weird... Yeah, max width is 15mm. Let's go with 20. There's a reason for not changing the thickness. Wait. That looks bigger than the 15mm one that I picked before. The 30mm one that I picked before. Like, there's a reason for not having really sudden width changes on yeah, there's a reason for not having really sudden width changes on high frequency signals, because you basically change the impedance of the line. Yeah, it's a differential pair. I don't know why it goes crosshatch when I do that. It's really weird. I guess I'll find out later when I go to put this through DRC. It might go, I don't like that. It's probably complaining that I've moved them too far apart. That's probably the reason. It's probably going, oh no, you've moved it really, really far apart, and that's terrible and broken, and you shouldn't do that, which is wrong. It doesn't matter. And it should shut up. It's a fact. So yeah, let's do that. Oh, that's pretty. Like, I know I could just have it with a little thing, but come on. Like, just leave it like that, it's fine. Like the little necks, it's nice. Cool. That seems quite reasonable. And then these would go, yeah, pretty much like this. That seems mostly reasonable, right? This looks kind of weird, doesn't it? This like zigzag thing going on. Not that it really matters, because this top layer, I think I'm just going to have it ground poured anyway. And I'll just have the bottom as a, so it'll be ground pour and signals, and then on the bottom layer it will be a VCC pour. And that'll supply all my power. I'll decide later when I figure out how much of a pain in the ass that's going to be to ensure that power gets everywhere with no loops and any weird crap, but I think it's okay because I'm routing a very small number of signals on the bottom. So we need a via here for VCC. So this is for VCC. Oops. And again, like, that's fine. Yeah, that's fine. In fact, I'm even going to go as far as actually just not routing any of the ground signals, other than these when they're like really close. Because, yeah, I'm going to end up doing a pour anyway. So it doesn't matter what any of these are, as long as I can get the grounds all connected up. Although this one I think is going to be separate anyway. This one is going to be grounded here. Oh yeah, because the fire's not. There we go. And that needs moving one higher. There we go. Yeah, like I could just connect. I like that you can change PCB 3. Yeah, exactly. Yeah, it's literally just 3 and 2. And then 1 is your planning view, which I pretty much never use. But yeah, so just 2, 3, 2. Quite useful. And then tomorrow I should have my 3D model coming for this particular part, which cost me 99 cents, and I still don't understand how that's economical, but whatever. Somebody's making me a 3D model of a Ethernet connector for 99 cents. Yeah, sure. That seems weird. It's from Easy EDA, so I guess. Yeah. Easy EDA. Sorry, Snap EDA. Snap EDA, that's it. It's something to do with DigiKey. I don't know whether they're like subsidizing it or something. But if you go to Snap EDA and you find a part, and then I don't know that it's whether you have to have clicked the link from DigiKey, because in the URL it does have and ref equals DigiKey. They have all of the symbols and footprints already done for pretty much, like, there's millions of parts on there for free. You just sign up and you just download them for free. But the 3D models they often don't have, so I was just like, oh, request 3D model, and then it was like, oh yeah, that's 99 cents. It's like, what? I don't know whether it's just your first model or something, or whether it's like once you click on DigiKey links or something. It's very weird. 99 cents is very cheap. They normally charge $29 to get it done, which that's much more reasonable, although it's still very cheap. Like, if you think about how long it would take me to put together a 3D model of that, like, even if it took me just an hour, which is short for something like that, $29? That's kind of cheap. Like, for somebody working full-time on this stuff, it still seems kind of cheap. So, I don't know. Could be interesting. We'll have to see what it looks like. They could just send me a square. It could just be a cube. That's it. Yes, here's a 3D model for your 99 cents. Yeah, exactly. Yeah, exactly. Like, I don't know what contracting rates somebody is on to build that for that cheap, but it doesn't sound very good. It doesn't sound like something that I would be happy being paid. Which is not that funny, to be honest. But I've got to assume that there's some weird economics going on there to make that happen. Oh, I love this track. What is this? Where's my... Of course, there's no track ID on this. Really good, though. Okay, it's got a list of artists, but not the timings. Of course it has. I'll have to remember this. 18 minutes into this video. Cool. There you go, Future Graham. When you watch this back, 18 minutes into this video. Dark synthwave music, no copyright, best dark synthwave music. Which is a terrible name for a YouTube video, but there you go. Go and find out what that is, because it's good music. It's got to that point where I'm talking to myself on camera. Right. What was I doing? More wires. Oh, and I don't think my microphone can pick it up, but just in case somebody can hear it, I don't want you to think that you're going insane because you think you can hear the X-Files theme every so often. Because my wife's in the other room watching the X-Files. And that explains why you can hear it. Maybe. You probably can't hear it though, because it is in the other room. But I'm just picturing somebody going through all of their browser tabs going, What the hell is playing that weird noise? And I've done it before. Although the worst one is always when somebody has somebody's streaming and they've got their like Telegram or Slack or something open, and they get a notification. Because the first thing you do is you go, was that me? Like, have I got Slack open? Looking for the person that messaged you, and it wasn't for you. I'll be honest, I have never watched X-Files really. Stargate is excellent though. Stargate's great. I love Stargate. Like particularly the sort of middle set of seasons of Stargate were really good. I also quite like Farscape is fantastic too. Farscape's great. I need to rewatch Farscape. I'm currently in the middle of watching Discovery. I'm rewatching seasons 1 and 2 because it was ages ago that I watched it. Because season 3 is out now. And I've heard mixed things about season 3, but I'm still going into it expecting it to be pretty good because I don't really have a reason not to. Yeah. And then I am in desperate need of getting back into watching The Expanse, because The Expanse is just great. But again, it's been so long since I've watched the first couple of seasons that I need to go back and rewatch all of it, which is an undertaking. This is just a good playlist, full stop. Hey Lynn. How's it going? It's all good. Don't let me keep you awake, Christ. Cool. So let's get this next set of resistors in. So it's going to be what? R7, 8, 15, 16. Let's see what's going on with this. So, how did I do this last time? This was like this, right? Yeah. And a little closer. No. It is this far apart. This is correct. Like, can't say much for the game itself, but I'm quite happy that the release of Cyberpunk 2077 has led to this like massive increase in the number of decent like dark synthwave playlists and dark synthwave mixers on YouTube, because obviously everybody's suddenly obsessed with it. It's like, I don't really care about the game, but yeah. Good music. That was rather weird. Sounds like the Knight Rider theme tune. No, sorry, Airwolf. It's got to that point in the evening. Hey. Oh yeah, okay, that's correct. This one's C11. See, this is where using hierarchical design would make more sense, because I could have laid this section out once and then it just automatically had it repeat for each of these. But yeah, I can't bother to go back and fix that and like manually set that up. But yeah, this is a banging playlist. And it makes me miss like revision and outline and Tresac and all of that. Particularly revision and Tresac for the music stuff. Like, that's a lot of fun. What is this? What is this? Why? Why you do this? There we go. Super weird that this is like... There we go. Why am I have to fight this so hard to get it to look shiny? What's this? Where's this shit? Why? Just... There we go. Altium. Why? Oh, that's why. Because that's not in the middle. It's got to be in the middle. I think this... Yeah, that cap is actually slightly low. That's why. Yeah, I've got it on a 5mm grid, so... Again, why is it being such a bloody pain in the arse? There we go. That looks fine. Might shift this over a bit. Oh, of course it does that. Oh, yeah, it's because it's, yeah. Oh, God. Aesthetics. It's my Achilles heel. I'll spend like 4 hours doing this, and it won't make a slight bit of difference to the functionality. None. None at all. Right, what's going on here? So we got all of that hooked up. I think this is going to look really nice when it's done, because with that like really dense, symmetrical look. I like things that look dense and symmetrical. I know this track. Yeah, it needs to be pretty. I still haven't decided whether I'm going to put some silkscreen art on this. I might do. Excuse me, cracking my knuckles. I'm sure freaks some people out. Yeah, this is definitely something to do with rules, because as soon as I put in these like fat traces, it goes, no! Yeah, silkscreen art. As in art on the silkscreen, you know. Top overlay. Drawing things on the PCB. I had a few ideas, but I don't know. I don't know whether you've ever seen... Okay, I can't possibly do this because this was custom done. But I got this pixel badge. I don't know how well this is... I can't remember whether I set up autofocus on my camera. Let me just check my camera settings. Oh, did I quit the camera settings app? Oh, I did. Just let that load. Yeah, I got autofocus turned off. Let's turn that back on. So... Oh yeah, hang on. Let me get this in the right view. I think the girls with their nails done now. Check this out. Like, how pretty is that? Like, that is so pretty. Yeah. Yeah, it's a really, really cool little device as well. I've been playing around with it. It's a lot of LEDs. It gets very warm when you... one of the devices on there, I forget which one it is. I think it's the... I think it's a Zener diode that they've got on next to the switching regulator. Gets very, very warm when you're hitting all the LEDs at high brightness. Like, I think they probably are pushing it on the thermal limits of that thing. Although I did leave it running. Sorry, I just heard the Stranger Things opening sounds and just... Ah, that's a beautiful noise. Yeah, yeah, I left it running for like 2 days with a very, very bright pattern cycling on it, like a rainbow pattern cycling on it, and it didn't die. But yeah, it was that diode gets too hot to touch at that point. It's like you can put your finger on it and then you're like, oh no, that's too much. So it's getting kind of warm. Although, I mean, the fact that I can hold my finger on it for, you know, even half a second before going instead of just an immediate means that it's not crazy hot in terms of operating temperatures, but it's pretty warm, really warm. Right, so what's next on here? It's going to be R9, 10, 17, 18. It's the final season of that is this year, right? Stranger Things? I think it is this year. I know that they were saying it was either going to be another October release this year, or it was going to be next year, like the very start of next year. I can't remember. I think I've also got season. Well, I think it's technically called season 2, but it's sort of season 3 because they released season. It's confusing. I think it's supposed to be season 1, part 1, season 1, part 2, which is what's come out so far of Disenchantment, and then season 2, part 1 is coming out, which I think most people are just calling season 3. Yeah, that's coming out in 5 days, which is one that I've been very much enjoying because it's hilarious. What else we got? C11. No, C12. Now I actually wonder. No, I will leave it like this. What I was thinking is I might flip the caps the other way up. Just have them like pointing in, pointing in, pointing in, pointing in. But I think I'm just going to have them going down. Oops, that's not what I was trying to do. And then let's copy that. Right, see you later, Pyro. Have a good sleep. Cheers for hanging out. You know what I just realised I can do? Bye. Save me having to faff about with all this routing again. Just. By the way, if there are any Australians here, I hope you're enjoying me say the word routing a lot. I don't know why there would be any Australians here, but I'm sure that's hilarious to anybody who's Australian. For those of you unaware, routing in Australian is basically fucking. And no complaints. You all click the I'm okay with the mature content on stream. Right. So it's just now 11, 12, 19, 20 for this last one. So let's move these down. What time is it? 20 to midnight, that's fine. I'll at least keep going for a little while. Might need to be a part 2 of this one. And then it's going to be C13. So then if I just copy these again, drop this into here. Oh, that's much faster. And then... Oh, yeah. Turn that off. Cool. So that's starting to look pretty legit. Do the same here. So then these are going to come out here, and these are going to be 3.5, I think. Or were they 5? I think these are 3.5. Let's find out. Yeah, no, these are 3.5. Yeah. It's just a case of it comes to here and routes upwards. I just remembered, that's why. Weird. I don't know why it's been weird. Routing very differently on this side. Maybe it's because there's already copper there or something. Whatever. I do not care. Pretty legit. So sure I'm into this weird siren thing that's going on here. Bit weird. Huh. Right. Well, that's starting to look pretty good. Dense. Don't think this silk screen is going to fit. Somehow. What the hell is that noise? Some of this music's really weird. Very odd. I guess I can just flip this like this way. Get in here and then shift this over. Seemed reasonable-ish. Like, I know I don't necessarily need to keep the part names in all of this, and then I could just like refer back to a reference design, but I really prefer to have them on the silk screen. Oh yeah, but that just means that the yeah, that's gonna get messy, isn't it? Because like, you go 1, 5, 2, and then where the heck does the 6 go? What, here? Guess it can. There. I guess that's fine. And yeah, I think that's okay. Yeah, I'm pretty sure that's okay, because it's going to be slightly confusing, because it's going to be like, wait, which one of these is which? But I think it's not too bad, because you've got like this. It's quite clear that this would be 1, which would mean that this would have to be 5, because this wouldn't be 2. Which would mean that this is... Wait. No. What? Oh, that's this. Why was that up there? Very weird. Yeah, okay. So, no, this makes much more sense. Yeah, because then it goes like 1, 2, 3, 4, 5, 6. Yeah, that makes sense. Like, and I know somebody's going to watch this and cringe that I'm, like, moving decoupling caps for the sake of, like, part identifiers on the silk screen. But I am, so deal with it. Music is very variable in intensity. It's going from screaming in my ears to just yeah, a little weird. I would listen to something. It sounds like I'm complaining. I'm not really complaining, but I would probably listen to something else if it wasn't for the fact that all of this needs to be copyright free and blah blah blah. Oh, now I see why I moved this hug screen up the top, because I thought, yeah. Explains that. So this needs to move across to make way for this thing. Right. No. Yeah, okay, that makes sense. And then this moves across one. Yes. Yeah, looks about right. Yeah, I'm not connecting up all the wires here because it's going to be a ground pour anyway. I'm not even sure that I actually want this many wires here because I don't need one here and one here and one here. This is just a signal wire, right? What's this? What is this pin? Designator 5. You're useful. Oh no, pin 5 is the actual. Pin 5 is the actual ground. Huh. So all three of these are just yeah, they don't need like a low impedance path. Well, I mean, they don't need a super low impedance path to ground. So I can get rid of that because, particularly for these two, because they're so close to this connector that's just got a ton of grounds on. So that's fine. I'll leave these on, I think. It depends how I flow some of the other signals, although I can't see why I would need to flow anything through here. So actually, yeah, I think I am just going to leave these without a local via, because I don't think they need them. Like ordinarily, I would say that, well, I say ordinary, like usually I would say, yeah, you know, just stick as many as you like, but it's just unnecessary. Because this is basically just going to be all ground pour on the top. Apparently this ends with 3 minutes of silence, so congratulations to whoever made that. There we go. Right, where are we? Yeah, I think that looks quite nice. Like, that looks pretty legit. Right? Like, that's pretty legit. So then... And I think I'm doing quite well here because I think this is gonna at least, like, let me just put a let me go on the dimensions layer and just add a dimension here, a linear dimension from, let's go in 100 mil steps. Let's go from here up to, yeah, about here. That's only 2300 mil. So even if we include some fairly sizable mounting holes for this, 25, I think 2500 is more than achievable in vertical space. So I think we can actually shrink the board vertically down to 2.5 inches. I am still concerned about how much horizontal space we're going to take up, but if this is a reasonable representation of the other side. Now, vertically on the other side, I do have additional parts. I've got the resistors on the top and bottom sides. Because if we look on here, I know they're DNP, but they still need footprints placing. So these, like R24, R44, and the same on here, also needs to be on the top and bottom sides. However, this is not, I don't think that's going to take any more vertical space because the resistors can just fold down this way. And we've already got the capacitors there, which means that we've got the space for that here, and then, or they can go upwards. So it's not really going to take any more vertical space, and it won't make any more horizontal space, which means that if we're effectively doubling this and then putting it here, like, yeah, we've got to do some crossover bits here, but that's not too bad. I think we're doing pretty well for horizontal. I think I can maybe knock half an inch off and have it 3.5. Like 3.5 by 2.5 would be quite nice. Because that quite significantly reduces the amount of space it takes up in the enclosure. And the more space I can take away on the inside, the more space I've got for like cable routing on the inside. Ugh. Excuse me. Tired. So yeah, those are the LEDs there. And then you've got the 2 holes and then the shields. Yeah, that's the only other tricky bit, is also on, I think on the bottom layer. Although, I think I can also do it on the top. Yeah, I can do it on the top layer, I think. And what I basically need to happen is have a trace go loop round like this. And that will be the shield connection. And one of the things that I added since the last stream as well is up here. Here. I added a jumper to connect shield and ground together. And that's just in case I want to do that. Because the idea is that the shielding on the... Excuse me. The shielding on the cable, because I've got a ground connection that's coming through the switch mode supply that brings the 24 volts down to the 5 volts, and then I've got a ground connection that comes through the shielded part. I don't necessarily want to connect those together because you can get ground loops, because if you think about it in terms of if the two of those are at different potential, a current is guaranteed to flow. So by bringing them together, you're creating a current in a loop, and that's a bad idea. So generally, I don't think I'm going to want to connect the two together, and that jumper will just stay unpopulated. It's also a useful thing to have on the board because in the deployment scenario, I can then put a multimeter in voltage mode over those two pins and find out what the difference in ground potential is, and that can tell me exactly how bad an idea it would have been to just directly connect the two. But as long as the shielding is one continuous ground reference, that's fine, even if it's not necessarily grounded in terms of being on the signal ground, being on the power ground of the boards. It's sort of like a separated ground, but I guess I'll find out later as to exactly how much that matters. Or excuse me. So yeah, I think I'll just move that over here now, because yeah, and that can go there. Wait, why have I still got the 100mm grid on? There we go. So I got a nice little what is that on about? Collision? With what? Collision. Weird. It's very strange. I don't know what that's about. Anyway. So yeah, that would be basically just a jumper. I think it's plugged in. So next, what's of interest? I've got all the decoupling caps in on this side, yeah? Yeah. So I think the next thing I want to do is... yeah, I think I want to get this routed on this part. I think that's quite reasonable. Yeah, and then this needs to come up here. Oh yeah, this was the one where yeah, it is slightly weird. Yeah, the room. The other thing that I think that sometimes happens is that it doesn't do a full DRC all the time because that gets kind of like computationally expensive. So I think what tends to happen is it'll do a like partial DRC all the time, and then when you do a full DRC, it goes away. But yeah, hard to know. Now, I'm trying to decide. I think what I'm going to do is, for a start, I'm going to get rid of that and that. Let's move this up. I'm going to route this upwards and across. I'm also going to change this size because 15 is excessive. I think I'm going to go down to 5 for this because that's silly. Yeah, I just don't need a 15mm trace on that. And it's going to be much easier to get this channel 4 line. And technically, it would be better to route it round this way. But that potentially complicates... Or does it? Actually, no, that doesn't complicate it, because... Yeah, that's fine, I think. Yeah, like, you see how I just undone this, and it's just decided that this isn't okay? Even though... there's literally nothing wrong here. Like... It's very weird. Like, DRC just gets itself... Like, the dynamic DRC just gets very confused. So yeah, normally I wouldn't then go and route round the front of this because it seems weird to do it that way, because obviously why would you not just have it around here? But there's nothing getting in the way on this side because we're just routing these 4 signals forward. We don't care about this ground because these are all on the ground layers in the middle. So when I route this, I can actually route it all the way around. Let's go about here and then. Yeah, so that's actually fine. Yeah. And then this one. That's reasonable. It is kind of ugly. Yeah, I don't like it. I think losing that 10-ish mil of okay if I do this. Oh, that's tight. But it fits. What's bothering me here is that these are very close. They've got ground references nearby, but they're very close. So, instead, what I'm going to do, I'm going to have this come very close to the ground line here. Like, really close. And then I'm going to actually route this around the back, because the ground lines here are just going to reference to this other... yeah, I think this is fine. Because the ground pins here will connect here, which then goes through to the ground plane, which is fine. And this distance here, like this is what, let's say. Okay, so yeah, that's like 25 mil. And the gap between layer 1, let's just check the stack up. The gap between layer 1 and layer 2 is 7.8 mil. Which means that we've got a, what, 4 times the distance between these two and the layer below, the referencing layer below. And it's pretty close to a ground pin. So this is probably not going to cross-talk onto there. And I think actually when the ground pour comes in, it will probably cut through there just, maybe, depending on how close it is. In fact, let's just try that now quickly. I'm going to place a polygon pour, and I'm just going to sort of put it over here. Like, it doesn't actually matter what shape I make. And then let's make that ground, pour over same net objects, and then re-pour it. Yeah, so we get this ground pour coming through here anyway. So this is going to be way better reference to ground. Like, there'll be no crosstalk there at all. Yeah, there's absolutely no way that that's going to crosstalk. Fun. But yeah, I think looping around the back there makes more sense, because bringing that close to channel 4, because these are again, these are single-ended signals, and they're different signals, so you do want them separate, because otherwise they will crosstalk. So next part is, let's get this TVS diode set up and doing what it needs to do. Yeah, about there. So then channel 2 comes down and connects to this, and channel 3 goes to here. Channel 4 comes up the side here, and channel 1 comes up and over. Actually don't like that this is like not connecting to the center there, so I don't like to do it this way, even though it's non-ideal. There we go. That's quite nice. It's actually a shame that I didn't flip this round the other way because there's a ground pin right there. I might do that now actually and just signal swap all of these around. Yeah, I might do some pin swapping on this because yeah, pin swapping. Can never find it on here. It's here. Oh, you have to save the whole project. Wow. No parts have been enabled for pin swapping. Oh, that's why, because I haven't enabled it for pin swapping. Ugh. So yeah, interactive pin and net swapping. Oh, and I can't pin and net swap them because I've connected them. So that's irritating. So yeah, so it needs to be effectively like shifted around clockwise. Sorry, counterclockwise. Because, well, either way. So, oh, right, yeah, no. So what I need to do is flip this round like this. Oh, there was copper under there. Okay, that's fine. In fact, let's just go, just select tracks and delete any weird copper that's buried under those. Yeah, of course there was copper hiding under those. And then go back to that. So yeah, this needs to be what? 1, 2, 3, 4. So what is it? It's 1, 2. So 1 needs to be up there. 2 needs to be up there. And then that seems right, yeah? 1, 2, 3, 4. Yeah, that's correct. So this can then connect. Oh, whatever. 3, 4, 1. There we go. That's nice. I like that. So then we just need a... Now, I could technically put the wire here and have VCC come in here, which would save some space. Do I want to do that? Kind of do. I kind of want it to be on the lower side though. Or do I just suck it up and put it there? I think I might just have it here. That looks okay. Yeah, that looks reasonable. Now, what might actually look better, now I think about it, excuse me, is because So this ground pin is effectively the center of where all of the signal lines are. So this ends up looking more symmetrical. Oh, that's much prettier. And that's what's important, right? No matter that it works. No. And you are supposed to be like that. There we go. Yeah. See, it would be nice if this TVS could sit on this left side, but it can't, because there's no way to route these signals back through. Because there's enough sort of dead space here that we could shift this across and then not take up quite so much here, but I think it's okay. I don't think we're quite that pushed for space on this side as I thought I was. Maybe... I think we can shave a little bit off the board width. I think. Not to be confused with the board rate. That's very different. So... might do the power. So both of those go into a fuse, which is this one. So yeah, both of these go into this fuse here. I'll move this down the side. And then there's this transistor, which works as reverse polarity protection. Just a nice little trick. What's a reasonable way to do this? I think it's going to have to go like this. And that's... damn it. There you go. Yeah. So that's going to go into the fuse, into the gate, I believe. No, into the collector. Yeah, through the fuse, into the collector. Then that provides VCC. Yeah. Because the idea with this is that the PNP, well, the P-type MOSFET turns on because the gate voltage is lower than the collector voltage. So it allows current to pass. Whereas if you put a reverse polarity on this, the voltage on ground is higher than the voltage on the collector, which turns it off and doesn't allow the voltage to flow. Ideally, I'd also have a Zener voltage clamp here, but I couldn't find a cheap part that would do what I want it to do without it being in the extended list, which was going to cost me a bunch of money just to put on something on here. And with this SRV05 having a 5-volt clamping Zener across VCC and ground anyway, it's kind of further into the board than I would normally like, but it'll do. I could technically have just taken this exact same part and put another one on over here and then just not used any of the other channels on it and just literally used it for the Zener. But yeah. So, and the C1 I think was up here, yeah, which is a 10 microfarad Is it 10 or 1? I think it's 10. Yeah, 10 microfarad ceramic. So that provides VCC for the board. Yeah. Kind of want to put this like over here. Just make this a bit more compact. Because yeah, there's nothing to stop me doing it this way, and it doesn't really make much of a difference. Like, that's nice and neat. And then this can be routed like this. To be confusing. I mean, ideally what I'd do is this. There we go. So that's quite nice. Although weirdly you get this like one connection here. So I should probably like do something more like this. Maybe pour it. Really? Oh, okay. Right. There we go. Oh, it's just... That's annoying. There we go. That's a nice connection to that part. Not that it makes a huge amount of difference, but... And then... Oh, sorry, I just saw your comment there. What's said about someone using... What on earth? Oh, yeah. I think I've seen something very similar to that with Marco Reps on YouTube repairing or looking at some very high precision measuring equipment, and they had some thermally stabilized like ovens with some op amps and various other things in there, voltage references, and they were being heated by I think it was like I think it was resistor arrays, if I remember correctly. And they were literally just using like a resistor array package as a heater, because they got that nice like potting around them, which distributes the heat quite nicely. Gives you quite a bit of surface area, which I thought was quite cool. So yeah, then we got this VCC going to a via. And for this one, I think I'd use I don't suppose it actually really matters how big this via is. Just for my peace of mind, I'm going to change that to some big chunky via. Otherwise, I'm just going to think about, why didn't I make that one bigger? Even though it's literally not going to make a single bit of difference. Oh yeah, I forgot. You need to mark that as... And actually, don't want that there. I want it here. Yeah, I think that's quite nice for the power. Move that there because I'm going to put some proper text above it. In fact, I'll do that now. Go to the top overlay, place string. For some reason, it's in mirrored mode. Probably the last time I used it was in mirrored mode. Let's center it here, and this should say what? Minus, minus, plus, plus. And if I make the text height 55? 40? No. 50. Looks about good. There we go. That's quite reasonable. Yeah. Now, normally for the power, I would have put a like a terminal block or something here. I might still change that later. Like, I might still rotate this whole thing 90 degrees counterclockwise and have this as a terminal block that sits on the edge here. Because that can be quite useful as well. And it's not much like rework to do that later, but I think I will do that later. I also think I have a part in, it's not in my main library, it's in one of my, it's a second library that I did for a different project that's got a nice, terminal block in there, 5.08 millimeter pitch terminal block with a 3D model that I made. So I think that will work quite nicely. Not sure what that is. It's a little weird. Right. It is midnight, so I might call it shortly. What's left to do now? Is it just the other side of this? And then the LED stuff? I think it might be. Do the LED stuff for this side first. R1 and R2. Yeah, I'm getting kind of tired now, but I'll do a little bit more and then I'll call it a night. See, this is another one of these things where I like this very odd error here. Like, what's this about? And it makes me wonder whether, for some reason, a bunch of my parts, like, you know, I was getting that issue with like the multiple pins. I wonder whether some of these have just like doubled up their pads or something. It's very strange. Like, there's an implication that there's something under here. But there's nothing here. It's literally just this pad. It's very, very weird. Yeah, I've got to be really careful with these because the extent of the part is quite a lot bigger than the extent of the footprint, I think. So I don't want these too close. In fact, I'm going to move these like a fair way back. Also, I'm not sure that that's on a grid. Is that on a grid? Oh, it is. Interesting. So yeah, I'm going to have that there, and then I'm going to have this one on the other side. Again, quite far back. Yeah, it's very strange. Oh, that's a good point, actually. Yeah, maybe these have got pads that are like multi-layer pads. No, these are on top layer. This is just very weird. I'll go into the footprint in a minute and have a look. In fact, I'll do it now. Let's find out what that is. The annoying thing is that if this is a generic footprint, if I remember correctly. Yeah, it's RS485, which is a generic footprint that I created. And if this one's broken, they might all be broken. And that's going to be very annoying. But I don't think there's anything in here. Like, there's nothing hidden under these. That's the marker for all of this. These all sit on mechanical 13 because they're... It's very weird. I think that's the one I started with. I believe it is. Yeah, it's really weird. I don't know why it's doing it. It'll probably go away when I do a full DRC, but I'm not doing that yet because I can't be bothered. So let's move that to like here. See, it's changed sides this time because it was on the other side before. So I really don't understand what. No. And then similarly, I will move this one to here. Yeah, getting these like really odd collision things going on here, but who knows? Yeah, it's very strange. I think that's okay though, because like that's quite a bit of space, and if I move that down the bottom, just to be nice and neat about it. Don't know why this one needs a locating mark, because you can't plug it in the wrong way. It'd be quite difficult. At least for now, that's okay with me. So then, I think we can move this back pretty close. Also, this is not symmetrical for a start. I think that's symmetrical. Now, how much space do I need to route this? Not that much, I don't think. I think even that might be like excessive. Wrong trace, but yeah, I think even that might be excessive, because if this is basically going oops. Like, let's bring this over to here and then go. Yeah. Yeah, I think this can actually be even closer than that. So, oops. Yeah, 10 mil grid. Yeah, I think that's not too bad. Because, so this is gonna come, what, yeah, up here. Yeah, so I think this comes up here, and then we go no. Let's move this back down. This comes through here. Actually, no, this is on the upper side of that. Basically, yeah, it's going to come through here, and then... yeah, because this one here... is going to... Now, ideally, actually, these want to be as far apart. Well, they want to be further apart than they are at the moment. And they only want to share that very close space where they absolutely have to for the shortest amount of time possible, because you want the least opportunity for them to crosstalk. Now these can go very close together. They don't have to, but they can. And in fact, I'm going to keep them very, very close together all the way up to there. And I might even go as far as... not that it really matters, as was discussed before. Actually, I don't like that. I think that's fine. It's not about keeping the it's not about keeping the differential pairs together. That doesn't actually matter. Like keeping the two lines of the differential pair together. What matters is not bringing an aggressor, that is another signal, closer to this signal than the ground plane is, by like a factor of a certain amount. And in this case, unfortunately, I have to. Like there's no way around. Like I can't get this signal, I can't cross these signals over here without swapping layers, and I don't want to do that. So yeah. Yes, but for 800 kilobaud, it's fine. Like the length matching doesn't matter within the couple of, tens of millimeters difference here. Like you can go way outside of that. It's fine. Yeah, I guess that's fine. And then we've got what? These last three signals. So this one comes out. It can come down here. Yeah, I'm gonna do all of the line length checking later, but I think this is fine because well, the thing is it's the rise and fall times that screw you, not the data rate. That's what screws you. It's why you can take a design from like 1975 and then remake it today and it'll fail EMC. And it's got nothing to do with if you built that exact, if you took the original product from 1975 or whatever, 1980, it's got nothing to do with like EMC getting stricter. You could take that exact product from that time, built at that time with components from that time, and it'll be fine. It'll pass EMC. And then you'll take it today and it'll fail. And the difference is that it's die shrink. So you'll have shrunk the die, so the rise and fall times got shorter, so EMC will fail. And because the old tech had such long rise and fall times, you didn't get all of this EMI. That's why it's so much worse today, and you have to pay so much more attention today. It's always funny to hear, well, it's not funny, it's almost sad to hear seasoned engineers from that time go, oh, it doesn't matter, it doesn't matter, it doesn't matter, and then fail EMC. Sucks to be them. That is actually for a completely different one, so that actually does need to be there. So actually, because that's... Oh, wait, no, that is the other side of this signal. So yeah. I want to do that. I think that looks pretty cool. I like that. What I'd like more, though, is this, I think. Because then these signals are kept far away from the other two here until the last minute when they come past here. And then yeah. Yeah. I think I like that because like here these have to go past this these two aggressor signals, but they're close enough together that it's not a problem. It's not that much of a problem, at least. Like, what's the closest here? Oops, didn't want to do that. What I wanted to do was go onto this layer. Ah, no. I don't want to select anything. Here we go. So the distance between this here and this line is like 10 mils. A little under 10 mils. I think that's okay. And like here, again, yeah, it's a little under 10 mils, but I think it's just over 7. And as long as it's just over 7, it'll couple to the ground plane, not that. Like, if I could move these... In fact, if I go back into tracks and go onto this top layer, if I can... Okay, let's turn the grid way down, like to 1 mil. That's... Okay, so that's within tolerance, so I can actually move these just 1 apart. But I think that actually makes a lot of difference in terms of... Well, it makes a little difference. Once you get them apart from each other in terms of... Oh, wait, no, hang on. Oh, I want the opposite of that, don't I? Because these two are the same. These are, yeah, in 1 and in 2. So these actually want to be as far away as possible from the... Yeah. So I want these to be as close together as possible, but it's actually more about them being further away from these other 2 pins. Like, and I can also just get that very close, which then means I can do the same thing here. Oh wait, no, these are different. So I'll keep these equidistant. Yeah. So these are then equidistant because these are different signals. There we go. And then this one I'm going to do the same kind of deal where I bring it down over here and then that seems reasonable. Like, it's not perfect, but who cares? I'm actually now wondering what happens if I move this part like way over here. Ah, okay. It stops the collision when I move it over here. That's why. I'm getting a part collision because of this PCB edge thing that's been written in here. That's why. For some reason, yeah, but as soon as I do this, collision. Collision. No collision. That's why. Yeah. So it's actually just wrong. But when I get the 3D model, I'll align all of this stuff anyway, because then I'll know exactly what this is, and I can take this text off because it doesn't need to be there, because I know what it is. I think that's just there for my information only, so whatever. In which case, actually, it's the this that needs collision turning off on this, but I'm not actually sure how to do that. And in fact, I think this should not really be on there. That should be on you know what? I'm deleting it. No, I'm not. Sod it. Can't be bothered. Right. I think I'm going to call it for the night because I'm getting very tired. And I can't see any like obvious thing that I want to work on right this second. Or do I flip the... Might do the signal flipping on the... Oh, that's interesting. And something I hadn't considered. How do I route that? How do I route that channel 3 and channel 2 back over? Although they are swapping sides. So I can route them on the bottom. So these can go on the bottom layer, actually, yeah. Because these can come over to, like, here. Because... yeah. Because these have got to swap over, because it's got to go... It's got to go 1, 2, 3, 4 upwards. I think. Yes, because of the... because when this goes on the other side... We've got pin 8 at the top. Wait. What? What the hell? Oh. These are all backwards. These should both be 4. Yeah. They should be 4, 3, 2, 1, not 1, 2, 3, 4, like this. Because... yeah. The only thing that should change, it should go negative, positive instead of positive, negative. And this should be this way around. There we go. Yeah, okay, so that makes more sense. So I now need to update the design. There we go. So, yeah, there we go. So that's 4, 3, 2, and then 1. Yeah, that's correct. So the first thing that needs to happen here, and I've got my weird drawing here. So 2 and 3 are now actually on the... So instead, I think what we got is 1... Oh yeah, I forgot I can't do this in the... Yeah. Okay. So both of these have to root underneath anyway. Oh, this is really irritating because one of the things about... Oh, no, that's fine, because... So these can actually go over each other because the... Oh, when I updated the design, I didn't back annotate the pin swapping I did here. So I need to delete these and do the pin swapping again. Yeah. So that goes to there. Wait, why is this being weird? Oh, I bet there's copper there, isn't there? Yeah, there is. So this and this, why aren't they changing? Oh, right, yeah. I need to have that. So it needs to be like that. Yeah. And then if I update the schematics, and then is that correct? Yeah, so that's now correct. So yeah, so these can cross over each other because we've got that a pair of ground planes between them, so they're fine to cross over each other. On a 2-layer board, you wouldn't be allowed to do that because any ground plane that you got on either side would end up getting cut by the signal that's going across, which would mean that as this went across, it would reference temporarily reference the signal going over it, and that's how you get a bunch of EMI and all the horrible things happening. Whereas this is fine. So. Basically, these two need to cross and these two need to cross. So 4 needs to go up here. 1 needs to go down here. 2 and 3 need to cross over as well. So I think all I'm going to do is basically just put a wire here. Just straight on that. Although not one that big. Oh, yeah, I forgot I'd got... There we go. So that's going to go on there. And that's going to allow this to come back up onto the next, onto the top layer. So that's going to go, like, you know, up this way somewhere. Like that. This is gonna yeah, cross over this way. Like that. Now in a minute I'm gonna fix it so that these don't go like 45 degrees, because obviously that takes up a ton of space and I don't want to route them like that because that just is too much space. But yeah, instead I'm going to fix this now. And this is going to go oops. So that crosses those two. And then between the two of these, excuse me. If it'll fit. I'm going to make this a ground wire. Because you want a ground reference when you cross when you cross layers. You want a ground reference that sits next to that via all the way up, so that the signal can couple to ground all the way through the board. Yeah, that'll do. So then the next thing I want to happen is, and also these don't need to be anywhere near as long. The next thing that needs to happen is this one here, this channel 4, needs to get over to the other side. And I think well, if I mean, this is going to have to come back up to the top layer anyway. So this can then flow over here and round. And up to here, I guess. Seems reasonable. I kind of wish this didn't take as much horizontal space up though. But I don't think there's any real solution to this other than like doing all the layer swapping up here and like routing up and round, which I don't like. It's kind of ugly. So I think this is okay. And again, this needs another ground wire. In fact, yeah, I was gonna say, can I make those any closer? And the answer is no. Yeah. So, just for the sake of it, I'm gonna just put a bit of So what's going to happen here is probably what's going to happen here is this is going to go like this, and then weird. That's going to come across and go into. In fact, what I will do is I'll put this here, and then I'll put another wire as close as I can, just there. And then this is gonna be channel 4, and that's gonna go straight into that. And then on the underside, this is going to come up and round. Like up here. In fact, I'm going to move this over, so this can actually go to here. And then this can switch back to the top layer over this side. Oops. And then on the top layer, the idea of what's going on here, which then means that we've got 4, 3, 2, and then the last thing to do is bring 1 over and round, and I'm effectively going to do the same thing again, which is oh, actually that's not what I intended to do here. What I intended to do here was not that. That was actually supposed to be a ground, and then it was supposed to be another one, and this was supposed to be channel 4. Oh, that's weird. There we go. So, and then this is supposed to come back here. And in fact, I'm going to go as far as putting another ground, yeah, here. And I'm going to move this. Here. So then we've got this lovely, like, barrier of grounds around all the signals. So then next thing is this needs to basically come over and do the same thing, which means this has to come back up. So in fact, what I might want to do is have this cross here, like quite early. Because, yeah, because that compacts this all down nicely. Let's go quite close to this ground wire as well. Not that it really matters, actually. I can go there. But it's just nice, and then that means that this can move back onto the top layer here. Like here. And then that's ground for this switching back to the top layer, which then wait, this needs to be on this side, I think. There we go. Yeah, I think that's correct, because this then goes up this way. Yeah. So if I just draw these as going like this far out. Also, this should be that. Just so that I know not to cross over. And then channel 1 from here is going to effectively do the same thing again, which is there's going to be a signal. Yeah, it's going to cross over like here. So this is supposed to be channel 1. And then we switch over to the bottom layer, which then comes over like here. Yeah, I think. Actually, yeah, no, I was wrong. Because this doesn't actually come back up till this close. So this goes over this side. And in fact, if I move this one over, I can also move this whole thing over. Yeah. Wait, what? Oh, no, I can't. But that's fine. So yeah, there we go. So that's nice. And then this can come down this side. As long as it's not too close. Yeah, that's okay. And that is preferable, I believe. So then we have this come down this way. Like to here. And then that goes here, and that goes here, and then we get a ground wire here. Yeah, that's too close. Yeah, so each of these signals then... Yes. So every time a signal swaps over, apart from up here, which I need to fix. So let's put this one ground. So there we go. So we got a ground wire here for where this changes layer. We've got a ground wire here when this changes layer, and we've got another one here. And that's all for this. This one changes layer, again, ground, ground. Another one here, ground, another one here with the ground. And then if I switch back onto the top layer and then we root out this one, we can see that this is also on the top layer, which then gets us 1, 2, 3, 4 backwards. Cool. I like that. Yep. I think I'm okay with that. It looks very weird. With all the wires in there. Peppered. I think that's the most confusing looking part of it, at least. But I think it's okay. And I think if I... yes, le spaghetti. But that tends to happen. It would probably look less le spaghetti if I just had like straight lines going around, and didn't need all of the wires and stuff in there. But whatever. Whatever. Yeah. The other thing is that if I do this. See, now that's kind of slightly more obvious because it's all in line. So you get this like in, out, out. But whatever. The last thing I want to do, and then I am going to bed because I'm getting quite tired, is I want to measure up this. So let's say this far. So that's about 1.5 inches. Okay. That's good. But it does mean, so if this is 1.5 inches to here, right? Not quite sure why it's drawn it like that, but so if this is 1.5 inches here, then like if this is the other end of this, then there's another 1.5 inches, and that means we can only take 350 mils off the end of this. So 0.35 of an inch is not a lot off the end of that. And I was hoping to sort of compress this a little more. Now, I believe if I optimize this a little bit, I can shift it left by what even is this? Like 40 mils, maybe like 30-40 mils out of that. I can probably save another another 20 mils here, but it's not a lot. So the width might be slightly more than I'd hoped. And the thing is, there's no real saving that, because even if I'd shifted some of these components over here, we're still sort of limited by what's in this center point. Yeah. Now, an interesting thing here is, so we're kind of in luck here, because we need to get this, we need to get power to this via here, this VCC, for the TVS diode. And luckily, the bottom side of this is going to have power flow here. See how we've got this loop here that's going to block off a lot of this. And one thing I've also got to be careful of here is I don't really want on the power on the bottom layer. I think this is okay because we've got this ground wire here, because otherwise what would happen is you'd get the power plane on the bottom flowing round here, and then back round here, and blocked off here, which creates this like loop around this, and you don't generally want that. Like, it's not terrible, but you don't generally want that. But because we've got these grounds here, what's actually going to happen is it's going to flow up to here, probably get in about here. Oh no, it will. It'll come back around here, won't it? Oh no, it won't. It'll hit this. Yeah, it'll hit this trace here, and it'll just stop. So yeah, it won't loop back around. So that's okay. That's fine. And in fact, I can show that now by if I go onto the bottom layer and then go place polygon pour, and then put a polygon pour on this bottom layer, and then connect this to VCC, and then set it to pour over the same net objects. Yeah, exactly. And remove dead. Oops. Remove dead. And then repour. Yeah, you can see here that what's happened is it comes round here, bounces around all of this, and then just stops. So you don't get this loop. Funnily enough, this is not this is kept, all of this round here, even though it doesn't really need to be, because the gap here is large enough for it to get through. But that doesn't matter, because that's just a bit of copper that's not connected to anything, so that's fine. But this is connected, so I would worry about this if it could loop back around, but it's not, so that's good. And you can see here that that's weird. Oh, of course, yes. So basically, none of this is connected because power flows just here. So this is where power comes from on the board. Which then the first thing that's going to hit is C1. So that's the reservoir cap. And then everything else, apart from that TVS, is decoupled. So we can see on here, all of these ground wires are here. What? So, one moment. Slightly confused as to what's happened here. I'm going to shelve this polygon. Oh yeah, they are for VCC. So okay, so they are connected. Yeah, polygon actions. Wait, is there no... Weird. Restore. And then repour. So yeah, okay. Yeah, sorry. I was looking too far left. So yeah, you can see these VCC pins here. These VCC pins are actually connected to the bottom plane, which is fine. So that's all fine because it's because this is on the bottom layer. You get like almost completely unimpeded, but not intended, almost completely unimpeded flow of that power pour on the bottom layer. For now, I'm just going to delete that because I don't need it there yet. I will work on it at a later point. And then the top is probably going to be a ground pour as well, because there's no reason for it not to be. And it does mean that because the ground pour can go nice and close to all of these differential pairs, it'll lessen the impact of aggressor signals being close. That's very, very, very close to each other. In fact, they are, if I understand correctly, those are 3.5 mils apart from each other. It's very, very close. Which, again, doesn't matter all that much for the fact that they're differential pairs, but it matters because they're further away from the aggressor signals. Cool. Right, I'm going to call it a night because it's 1:30 in the morning and I am quite tired. I got work. Haha, yeah. So, yeah, take it easy and thanks for hanging out. I might do another stream maybe tomorrow night. I know I've been doing a lot recently, but I may do another one tomorrow night, just carrying on working on this. Yeah, doing a bit more. And hopefully we'll get the remainder of this all routed and organized out and maybe shave some horizontal space. Just enough to be able to get cables and stuff in and out of the boxes. So yeah, thank you all for hanging out and hope to see you soon. Oh, and it helps if I can find where all of my controls are for doing things. I've got a Stream Deck and I just don't use it because I'm lazy. So yeah, thanks for hanging out and yeah, see you soon.